To make a histogram by hand, we'll start by creating a grouped frequency table. We'll carefully construct the groups so every datum in our data set has a place to go. We'll start by deciding how many bars or intervals we want to have in our graph. The standard is to use 2 to the power of k, where you get to pick the value for k so long as the value you pick causes the result to be larger than the size of your data set. Now in this case our data set has 100 values, so we can pick as many bars as we'd like, but we should have enough so that if we plugged it in for k here, it would be larger than 100. So we wouldn't want to use 6 because 2 to the power of 6 is only 64. We could use 7. 2 to the power of 7 is 128. Or we could use any number larger than 7. For this example, we're going to use k equals 8. So 8 bars or 8 intervals for that matter. Next we need to pick a starting point. We will pick one of the smallest values to help us find our starting point, but the other bit of information we must consider is how precise is our data. Looking at the data set we're investigating here, we can see the most precise data values go to the tenths place. We don't have any data values that have digits in the hundredths place. So in order for us to make sure that there's no overlap in our groups or our intervals, we're going to make sure to set our boundaries one place value more precise than what we have in our data set. So we need to go to the hundredths place for our precision. To find our starting point, I'm going to pick my minimum value from the data set, and I will subtract 0.05. The standard is to always use a half place value, so if we were at hundredths place in our data set, I would subtract 0.005, a half in the thousandths place value. But since our data set is precise to the tenths place, we'll subtract a half in the hundredths place. So 60 minus 0.05 will give us our starting point at 59.95. Next, we're going to pick kind of a test end point. So it's not the definite ending spot, but we're going to take the maximum value in our data set and push that out one more place value of precision as well. And this is just our temporary ending spot. We're going to use that temporary ending point with our definite starting point to calculate our bar width. So we'll take our starting place away from our temporary ending spot and divide that by the number of bars we've chosen. This is going to come out to be a decimal value. But to make things easier on ourselves, we're not going to allow our bar width to be anything but a whole number. So we just calculated that the bar width should be 1.7625, and if we do that, it will cause 8 perfectly uniform rectangles along our number line on the bottom of our graph, but I don't want to use that width because the numbers are going to be all wonky. I like to have it nice and uniformly spaced. So we're going to round this up to the nearest whole number. 2 is going to be our bar width. So every bar or every interval in our grouped frequency table is going to be 2 units wide. This will cause us to go beyond our temporary ending point of 74.05, but that's okay. It's not a big deal. Next, we're going to find our boundaries. So in our grouped frequency table, we need to create the intervals that tell us how to sort our data. So we need the lower boundary and the upper boundary. We know we're going to create 8 intervals, and each one of those intervals is going to have a low number and a high number. We'll start with finding our first group with our starting point, 59.95, and then we'll add 2 to that to get to our upper boundary. So our lower boundary is 59.95, our upper boundary is 59.95 plus 2, which puts us at 61.95. For that first group, or that first interval, we have our lower boundary and our upper boundary. When we go to make our second group, or our second interval, we're going to copy down the upper boundary from the previous group as our starting point, and then add 2 to that to get to the next upper boundary. We're creating our class intervals this way. So for our first class, we're going to put all of the data values between 59.95 and 61.95 in that first class. Our second class consists of all the data values between 61.95 and 63.95. So we'll continue doing this creation of these intervals until we have all 8 of our classes. Now we have our 8 classes. Each of them has a lower boundary and an upper boundary, and every single one of our classes is exactly 2 units wide. Now we're ready to sort our data into our frequency table based on the groupings that we just created. You may have noticed that the data is already arranged on the screen so that we can easily see each of the groups. All of the data values that belong to the first group or the first class are in this top row. I can count that there's 5 data values here, so I'll copy 5 into my frequency. Looking in this second grouping of data that we have, we can see these are all of the values between 61.95 and 63.95. There's 3 values there, so we copy that into our frequency table. And we can continue doing this for all of the groupings that we see in our data. Now that we have all of the frequencies written down for each of our classes, we can talk about whether or not we want to make our histogram using frequency or relative frequency. The graph's going to look exactly the same. The only difference is, are we going to denote the height of each bar in our histogram based on a raw frequency count or a relative frequency count? So at this point, it might be a good idea to calculate our relative frequency just in case we want to use it for our histogram. Relative frequency takes each frequency for each group and creates a fraction where it compares it to the whole. We know that there's 100 data values in our data set because there were 100 semi-professional soccer players surveyed, or at least their heights were measured. So I'm going to create fractions for each of these groups where the denominator matches the number of values in our data set. To create the actual graph, we first want to find a uniform grid to represent each of the bars. I'm starting with blank graph paper here, and I'm going to label my classes along the bottom axis, the horizontal axis in the graph. I also want to label the vertical axis along the left or even the right edge of the graph so that I can see the frequency counts relatively easy. I decided to count by 5s just because it matched up well with the graph grid that I'm using, but we could have counted by any denomination we'd like. Next, I'm ready to draw my rectangles. My first class, between 59.95 and 61.95, has a frequency of 5. So I'll draw that rectangle all the way up to the 5 line on the frequency axis, and I'll color that in. My next class has a frequency of 3. Now I don't have a line that marks 3, so we'll do our best to estimate about where 3 is here. Next class goes all the way up to 15, then up to 40. Next class is up to 17. Next class is up to 12. After that we have a class that's at 7, and our last class is at 1. There's our histogram.